Hello again, everyone. This is Mr. V. Hill, and today we're going to be talking about how to write general rules from recursive rules. So we're just going to do a couple of quick examples. The first one, here's a recursive rule. Start with 2 and add 3 to the previous term. So if we want to use our subscript notation, that means that our a sub 0, the 0th term in the sequence, really meaning the first one, but we're starting with 0 here, just for simplicity's sake. That's going to be 2. And then what we're going to do is, if we want to get to any particular term a sub n, we're going to take the previous term, which would be, of course, a sub n minus 1, and then we're just going to add 3 to that. Okay, so we've seen this particular sequence before. So the sequence is basically going to look like we'll start with 2, we add 3 to get to the 2 to get to the next term, that's 5, add 3 again, we get 8, add 3 again, we get 11, add 3 again, we get 14, and so on and so forth. And that's the same one we were looking at last time. But here's our sequence. We're given this recursive rule. Let's make a table and see if we can spot some patterns going on and see how we can get this to some form that we can write just a sub n in terms of just n, not in terms of the thing that came before it. So let's see here, we'll have n on the left hand side, and we'll put, I'm going to make it really long here because I'm going to have to do a lot of work down here, a sub n on the right hand side. So if a sub n, or if n is 0, then a sub n is of course 2. If n is 1, then we get 5. If n is 2, then we have 8. If n is 3, we have 11. If n is 4, we have 14. And so let's really think about this a little bit. So we want to kind of work with this table in terms of how the recursive rule works. Let me show you what I mean by that. So this 5, the way we got to this 5 from using the recursive rule is we just added 3 to the thing that came before it, to the 2. So we can, instead of thinking of this 5 as 5, we want to think about it as the previous term, which was 2, plus 3. Because that's exactly how we got 5 from the previous term. We added 3 to it. Okay. Similarly, this 8. We got the 8 by adding 3 to this 5. But we're no longer thinking of the 5 as 5, we're thinking about it as 2 plus 3. So really we're taking 2 plus 3, and then we're adding another 3 to that. Okay? This 11 we got by adding 3 to the 8. But we don't want to think about 8 as 8 anymore, we're thinking about it as 2 plus 3 plus 3. So we take the previous stage, 2 plus 3 plus 3, and then we add on another 3. Same thing here. 14 is now not 14, it's the previous stage, which is 11. But we're not thinking about it as 11 anymore, we're thinking about it as 2 plus 3 plus 3 plus 3. And we're adding another 3 onto that. Okay. So now we're going to go back and think about, remember that order of operations video we watched way back when? Actually just 2 videos ago. Notice what we have here. I'm just focusing on when n is 4. 14 was 2 plus 3 plus 3 plus 3 plus 3. This right here we have a repeated addition of 3's. So these 3 plus 3 plus 3 plus 3, that's 4 3's added together. So instead of thinking about this as 3 plus 3 plus 3 plus 3, we want to rewrite that as a multiplication, because a multiplication is this repeated addition. So this would actually be 2 plus 4 of these 3's. Look back here at this 11, which we wrote as 2 plus 3 plus 3 plus 3. Right there we have 3 3's added together. So instead of writing it like this, we can just write it as 2 plus 3 times 3. Back up here. 8 was 2 plus 3 plus 3. Again, this repeated addition, 3 plus 3 is actually 2 3s, or 2 of these things we're calling 3, so it's 2 plus 2 times 3. We could even do the same thing up here. 2 plus 3, well, we just have 1 3. 3 is the same thing as 1 times 3, right? So this would be 2 plus 1 times 3. And even back up here, when n was 0, this 2, we're not adding any 3's on. Oh, sorry about that. Somebody's working in the room right now. Hammering. But still, this 2 we could rewrite as 2 plus 0 times 3. Okay, so notice, when n is 0, we're adding on 0 3's. When n is 1, we're adding on 1 3. When n is 2, we've added on 2 3's. When n is 3, we're adding on 3 3's. When n is 4, we're adding on 4 3's. So, if we continue this down, I'll just put some ellipses, kind of say that this whole thing is going to continue on forever. So when we're looking at the nth term, notice, you see this pattern here? Should be pretty obvious now. We're always adding on that, whatever n is, that's how many 3's we're adding on. So, if we're looking at the nth stage, a sub n is going to be 2 plus n times 3. And that's basically your general rule right there. Whatever n is, a sub n is given by this. Now, we don't normally write it in this order, but keep in mind, of course, addition, you can switch around the order of addition, or even switch around the order of multiplications. So the way we normally write it would be like this. A sub n is going to be equal to, well, instead of n times 3, we'll write that as 3 times n. Now, you don't have to put a multiplication sign in between a coefficient and a variable. But then, of course, the plus 2. We're just going to rearrange the addition and then also rearrange the multiplication. And that's kind of what's called standard form, but we don't really need to worry about it too much right now. But that's the idea. So here would be the general rule for this particular sequence. And it's really easy to get from the recursive rule. You'll notice here that whatever you're starting with, that's kind of just this thing that's tacked on here, or here at the beginning. Whatever you're adding repeatedly, that repeated addition becomes a multiplication. You're adding on n 3's all the time, or 3 times n. Hopefully that makes sense. Now, let's try a little bit different sequence here. Example 2. This time, we're going to start with 2 again, but this time instead of adding on 3, we're going to multiply the previous term by 3. Okay. So, with our subscript notation, that means that a sub 0 is going to be 2, and then we get to a sub n, any particular term in the sequence, by taking the previous term, which would be a sub n minus 1, and we're going to multiply that by 3. So, if we were to write out the actual sequence itself, of course, we start with 2. The next term, we just multiply that thing by 3. So 2 times 3 is 6. The next one would be 6 times 3, or 18. The next one would be 18 times 3, which is 54. Next one would be 54 times 3. Well, that's 50 times 3, which is 150, plus another 4 times 3, which is 12, so that would be 162, I believe. And it would just keep on going like that. Notice this one's getting a lot bigger, a lot quicker. Okay. Now, let's do a similar thing to what we did last time. We're going to make a little table. N and a sub n. When n was 0, a sub n was 2. N is 1, a sub n is 6, 2 matches up with 18, 3 gave us 54, the fourth term was 162, and so on and so forth. Now, let's think of each of these terms kind of referring back to the recursive rule. We got 6 by taking the 2 and multiplying it by 3. So 6 we're not going to think of as 6 anymore. It's going to be 2 times 3. The 18 we got by taking the previous stage, which is 6, and multiplying that by 3. But again, we're not thinking of 6 as 6 anymore. We're thinking of it as 2 times 3. So we take that and we multiply it by another 3. The 54, we took the previous stage, which was 2 times 3 times 3, and we multiply it by another 3. The 162, we got that by taking the previous one, which was 2 times 3 times 3 times 3, and multiplying it by another 3. Sorry, this got a little messed up here. That's okay. Now, notice here, instead of a repeated addition, down here, we'll start with this row. Now we have a repeated multiplication. So that 3 times 3 times 3 times 3 is 4 3's being multiplied together, or we could rewrite that as an exponent, because a repeated multiplication is an exponent. So this would be 2 times 4 3's multiplied together is 3 to the power of 4. Similarly here, notice we have 3 3's multiplied together. So this is going to be actually 2 times 3 to the power of 3, or 3 cubed. Here, 3 times 3 is, of course, 3 squared. And it still works back here. 2 times 3, well, 3 can be thought of as 3 to the power of 1. And even back here, too, we could actually write that as 2 times 3 to the power of 0. Hopefully you remember that from last year. Anything raised to the power of 0 is 1. So 3 to the 0 is 1. 2 times 1 is, of course, just 2. Now, and that's not just definitional, there's reasons why, and we'll get into why something raised to the power of 0 is always going to be 1, except for 0. 0 to the power of 0 is something else entirely. But any number that's not 0, raise it to the power of 0, you get 1. But now, hopefully you'll notice here that the n, 0, 1, 2, 3, and 4, always shows up as the exponent in each of these expressions. So, extending this out, you should be able to realize that whatever n is, that's always going to be the exponent. This is always 2 times 3 to this. 2 times 3 to that power. 2 times 3 to that power. So, for an arbitrary n, a sub n is going to be 2 times 3 to the power of n. And that's basically our general rule here. So a sub n is always going to be equal to 2 times 3 to the power of n. And you do a whole bunch of examples like this, and you should quickly realize that whatever you're starting with, that's this number right here, the coefficient of the exponential expression. And whatever you're multiplying by all the time, that's the base of the exponential, and the term number is always going to be the exponent itself. So there is your general rule for this recursive rule. Okay. Hopefully that made some sense. If not, you can ask me some questions tomorrow in class, and we'll get a whole bunch of practice on this. Thanks so much for watching.